13.3 is about radian measure, and this is an aspect where we start talking about converting between radians and degrees. So in A, it says, what is the degree measure of -3/4 pi radians? So to convert radians to degrees, you multiply by 1/8 over pi. All you're trying to do is get rid of that pi. That's how I remember it. It's either pi over 180 or 1/8 over pi. So how can I get rid of the pi or introduce a pi if it's missing it? And that's just how I remember how to do it. So let's take -3 pi over 4 times 180 over pi. Why 180 over pi? Because what's going to happen here is the pi's are going to cancel. And then using your calculator, do -3 times 180 divided by 4, and that will give you -135 degrees. Now the opposite, going from degrees to radians, you're going to multiply by pi over 180 because radians always have pi in it because everything's in terms of pi. So 27 times pi over 180, which ends up giving you 27 pi over 180, and then just hit 27 divided by 180 and it'll reduce it for you in your calculator, and that's how you get 3 pi over 20 radians. Finding the cosine and sine of a radian measure, what are the exact values of cosine of pi over 4 radians and sine pi over 4 radians? Well, again, we probably ought to know that in a unit circle, we're talking about stuff here. This is 0. This is pi over 2. This is pi. And this down here, 270 degrees, is 3 pi over 2. If you're looking in radians, 90 degrees is pi over 2. 180 degrees is just pi, and then when you come back around to 360, it's 2 pi. So if we're looking at pi over 4, that's going to be right in that area here. Okay, so this is going to be pi over 4. So if I were to take 180 divided by 4, that's really the same as 45 degrees. So what I do is I want to find the cosine and the sine. Remember, let's make a right triangle here, drop that down. Okay, so how do I find that? Well, again, we have a 45, 45, 90 degree triangle. S radical 2. Okay. And again, since it's a unit circle, we know that the length of that is 1. So across from the 90 degrees is 1. Again, this the same, you'll see this over and again. Divide by radical 2, so S equals 1 over radical 2. Remember, multiply to rationalize. And you end up getting radical 2 over 2. That's going to be the same whenever you're talking about here, radical 2 over 2. So we're in the first quadrant, so they're both positive. So the cosine of pi over 4 is radical 2 over 2, and the sine of pi over 4 is the same, radical 2 over 2. If we're looking for the length of the intercepted arc, we did a little bit of this in geometry last year, but again, in radians, in terms of the radius, we're going to do the intercepted arc as S equals R times your angle in theta. So let's take a look at this as we go through. Use the circle at the right. What is the length S to the nearest tenth? So if we're looking at this, remember, S equals R times theta. So if we're looking at here, well, what is my radius? My radius is 3 times my theta in this case, which is 5 pi over 6. Go ahead and multiply through. You could just reduce. It's just 5 pi over 2. Okay. So again, they want it to the nearest tenth. So go ahead and use your calculator. 5 times pi divided by 2, which gives me about 7.9.